In this tutorial, we will learn about how to write a Verilog code for a half-adder circuit. So a half-adder circuit will have two inputs A and B, and it will have two outputs, which is sum and carry. So the expression for sum is given by A XOR with B. That is why we have XOR gate. And the expression for carry is given by A ANDed with B. So this represents an AND gate. And here we also have the truth table. So the basic job of half adder is to add any two binary inputs. So if you give 0 and 0, if you do addition 0 plus 0, so sum is 0 and no carry is generated. If you do 0 plus 1, sum is 1 and no carry is generated. If you perform 1 plus 0, then also sum is 1 and no carry is generated. But if you do 1 plus 1, so the answer is 2. But in binary format, 2 is written as 1 0. Therefore 0 will be go in sum bit and the extra 1 will go as carry. So we need to write a Verilog code for this, and we will be using our EDA playground online simulator for this. So I will be writing the code in Notepad application and then I will paste it here. So as any Verilog code will have two components. It will have a Verilog design code and it will have a Verilog test bench code. Design code is used to model the digital circuit behavior, and the test bench code is written to test the circuit. So coming to design code, let us first write it. Any key, we need to start with a keyword module, then give some name for your circuit. So I'm giving name as half adder HA. Then write down what all signals are there in your code. So I'm writing A comma B inputs, comma sum and carry. Then enter inside the code, declare which are inputs and then declare which are output. Next you say how do we calculate those expressions. So assign S equal to, if you remember from the circuit diagram, sum was given as A XOR B. So we need to write that symbol. And for calculating the carry expression, you need to perform AND operation. So do A ANDed with B. And then you write end module, because whatever module has been started, it has to be ended. So this is our simple design code. Now what we need to do is we need to write a test bench code for this. So let us write a test bench code for this. So write keyword module and give the name as TB. And before itself you can keep and write end module also. Now you come inside. Whichever things are declared as input in design code, those will become reg in test bench. Why they become reg is because reg signifies register and we need to store the input values in order to get the output. That is why whichever things are written as input in design code, those become reg. And whichever thing are declared as output, those become wire. Because wires output need not be stored. As long as the input is coming, the output will be continuously generated. Next thing what we need to do is we need to do instantiation. So we need to call this code design code. You can give some instantiation name and then you need to connect the test bench signals with the design signals. So I'm following port connection by order. So I will write the signals name in the same order as they are in design code and I will end it. Next you open a initial block and here what we need to do is we need to perform and give test signals. But in order to see the waveform, we need to write two files. So $dump file And one more is we need to give $dump vars. So these are two important files which you always need to write to get the simulation timing diagram waveform. Next, we need to write one monitor signal if we want to print the values also. So just see the syntax very carefully. So I'm writing time equal to percentage 3D because I just want 3 digits to be displayed. Then I will write a equal to percentage b because a is a binary number, that is why percentage b. Then b equal to percentage b, like that s equal to percentage b, and c equal to percentage b. Come out of the double quote. So whatever this percentage 3D is there, right there I want to print time. So you can use this directive $time. It will directly print the simulation time there. And all this I want to print the name of signals. So you can just write a comma b comma s comma c. So it is very similar to the printf statement in C language because Verilog language is very similar to C programming language. So syntax is very similar. Next, you can start giving the values. So because a full adder will have 4 input combinations, you can start giving from 0 0. So a equal to 0. Then you can give b equal to 0. And then you can give some delay of 20 seconds. Because at a time you cannot give all the 4 values. So you can give some delay. And after that, you can start giving new value. So I'll just copy this statement 4 times and I will edit it. So 0 1 1 0 and last combination is 1 1. After we are done with all the combinations, just at the last you invoke $finish to end the simulation. So this was our test bench code, and we also have our design code. So what I'll do now is I'll copy this design code and test bench code to EDA playground, and there we will run our code. So I'm copying first design code and I'm pasting here, and I'll also copy my test bench code. You can directly code in this EDA playground also. Just because I wanted to show with a bigger font, I was using Notepad application. Now see a few settings which are very important. So first thing what you need to do is you need to go to language, and by default always it is system Verilog only. So no need to disturb it. Then come to tools and simulators. In tools and simulator, always you select this Aldec Rivera Pro. Okay, once you hit on tools and then you come down, and then you need to click on open EPWave after run. This thing you need to always tick. If you don't tick this right, you will not get the simulation waveform. So always this tick should be enabled for open EPWave after run. So after you have written all the code of design and test bench and did proper selection of these components, hit on run button on this top. So after you have hit the run button, it will run on an online tool. So wait for some time because it's not running on your physical device. It's running on some output cloud server. And if you see now, observe carefully, down output will come. So let us just scroll this up and see the output. So neatly it has printed like at time t equal to 0, a value is 0 and b value is 0. Therefore, sum is 0 and carry is 0. Then time t equal to 20. For 0, 1, sum and carry values. Everything it has printed, all the 4 combinations. So you might get a doubt how we are getting this time as 0, 20, 40, 60. Because while giving the input combinations, we have given a delay of 20 seconds. So at starting time is 0. After delay of 20, we got this combination. And if you give delay of 20, after 20, it will be 20 plus 20, that is 40. And after 40, if you give 20 delay, then it will be 60. Let us observe the same thing in simulation timing diagrams. So this waveform will be generated. How you need to analyze this waveform is, first you click near 0 time. If you click near 0 time, you will get all the signal values A, B, carry and sum. So when A is 0 and B is 0, you can observe carry is also 0 and sum is also 0. Next we gave a delay of 20 seconds, right? Then click on 20. Then automatically you will observe that these values of variable are changing. So these A and B are input port, carry and sum are output port. Then for 0, 1 combination, you can observe carry is 0, sum is 1. Then come to 40 because we gave delay of 20 seconds. Then for 1, 0, carry is again 0 and sum is 1. And then come to 60. If you observe 1, 1, right? So for 1, 1, we got a carry of 1 and sum is 0. So you can verify with your truth table whether correct operation is coming or not. So hopefully you now understood how to simulate using EDA Playground. Thanks for watching.